History class with Zoe. Have you ever wondered why things work the way they are? You might be having a philosophical question right there, and thankfully I know someone related to that area of study. Interestingly enough, this philosopher might have been wondering the same thing as you did 2,500 years ago. Meet Leucippus, the first ever philosopher to theorize atomism, the idea that everything in this universe is made entirely of various unchangeable, indivisible elements called atoms. This does remind me, I had an important topic to talk about today. Yes, the atomic theory history. After all, this is a history class with Zoe. Let's get right into this. As I mentioned, Leucippus is the first recorded human to theorize about atomic history, but sadly there are not a lot of information on him. We only know about him through a more famously known philosopher named Democritus. He was also a Greek philosopher who was born around 460 BCE and is still famous to this day for his formulation on the atomic theory of the universe we live in. I just like to remind that his work was mostly reported second-handedly, which means it is somewhat unreliable, but then again it was the old days. He theorized that atoms are tiny, uncuttable, solid particles that are surrounded by empty space and are constantly moving at random. Back then, with our knowledge on science so undeveloped, Democritus had no way to prove his theories. We now know that some of his theories are proven wrong, which we will be getting onto that later. It is also known that Aristotle, a famous Greek philosopher, had rejected Democritus of his theory on atomism. The next major person related to our history on atomic theory is no other than Aristotle himself. As mentioned earlier, Aristotle is incredibly famous in the Greek philosopher society we have today. He strongly disagreed with Democritus' ideas of atomism and instead said that there were four elements: earth, fire, wind, and water. He believed that the smallest unit anything could be divided into were these four elements. Greek philosophers would often argue with each other on what was the main of these four. Of course, once again, Aristotle had no evidence at all to back his theory up, but since there were no evidences of anything related to atomic theory or atomism during that time, a lot of people would believe in his four elements theory. Skipping a lot of time here, John Dalton was born in 1766 and later grew up to become an English chemist, physicist, and meteorologist. He is well known for connecting the previously known atomic history and chemistry. The Dalton atomic theory was the first ever completed attempt to describe the rules and nature of atoms. He based most of his theory on the law of conservation and the law of constant composition. His view on atomic theory was that all matter is made up of atoms, which is indivisible, and that these atoms of a given element would be the exact same in mass and properties. He also theorized compounds, which he described as combinations of two or more different types of atoms. And lastly, he stated that a chemical reaction is basically rearrangement of atoms. The Dalton atomic theory had some modifications after the discovery of subatomic particles and isotopes, but so far, his theory is the most similar to the facts about atoms we learn today in contrast to the other two. Joseph John Thomson, more widely known as J.J. Thomson, is our next human related to our history of atomic theory. He was born in 1856 and later grew up to become a British physicist and Nobel laureate in physics. His theory, called Thomson atomic theory, was that all atoms carried a tiny negatively charged subatomic particle, which is the electron that we know of today. This is the guy that discovered electrons for the first time in human history. His theory of what an atom looked like was called a plum pudding or raisin bun, which was that negatively charged electrons were embedded within a positively charged soup. He discovered electrons by doing an experiment with Crookes, or cathode ray. He demonstrated that the cathode rays were negatively charged, hence meaning that they had to be a subatomic particle, which made the atom contain a negative factor in itself. His breakthrough helped the way chemistry works today. Without his discovery of electrons, we'd be far behind. Ernest Rutherford was a New Zealand-born British physicist born way back in 1871. This man is best known for his gold foil experiment, where he first discovered the nucleus and protons. With his gold foil experiment, Rutherford found out that most of the atom is empty space, with most of its mass concentrated in the center of a positively charged nucleus. What made the nucleus positively charged was soon discovered to be a positively charged subatomic particle called proton. Rutherford also went on to discover two types of radiation, alpha radiation and beta radiation, but that is more related to physics than chemistry. Rutherford's model looked like there was a nucleus in the middle with electrons wandering around about, which was later nicknamed as the egg yolk analogy, as it kind of looked like an egg yolk. Niels Bohr was born back in 1885 and grew up to become a physicist. It is known that he used to be a student of Ernest Rutherford. A lot of people studying chemistry know him well for his Bohr model, but he did a lot more than create that. He was the first to discover electron orbitals, which is that electrons orbit the nucleus instead of wandering about with no formation. His model reminded people of the solar system, with the nucleus in the center representing our sun and the electrons orbiting it looking like the planets. This was later nicknamed the planetary analogy. Sadly, the original Bohr model only worked for a hydrogen atom because he didn't know about the neutrons back then and did not include it in his model. Lastly, James Chadwick was a British physicist born back in 1891, who was the first human to discover the neutron. This was a huge discovery, as it did not have any positive or negative charges, but it did contribute hugely to the atom's mass along with its protons. This huge discovery led Chadwick to win a Nobel Prize in Physics in 1935, 3 years after his discovery of the neutron. Without the discovery of these men and many other people, science today would simply not be the same. For example, it would not be possible for us to have online classes during summer because technology would have been way less advanced without the knowledge that these people have discovered. We have so many future possibilities with the knowledge we have from this alone, and excites me and scares me at the same time. We have so much potential to improve what we have right now with the knowledge we learn. To close off this video, I am very grateful to live in a planet where we figured out how atoms work, and I am excited to see what future this information can bring upon us. Thank you for listening.